It's Geometry, Notes, Section 3.5, Equations of Lines in the Coordinate Plane. First thing we have is the slope of a line formula. This is lowercase m equals delta y over delta x. Delta means subtract. It means difference of y's over difference of x's. If you prefer, you could write it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. These little sub numbers, sub is short for subscript, just means your first x value and your second one, your first y value and your second one. Could you do y sub 1 minus y sub 2 and x sub 1 minus x sub 2? Absolutely, doesn't make a difference. Slope-intercept form. This form is useful if you know the y-intercept and you know the slope. Keep in mind that the y-intercept is a specific point. This is the y-intercept, also known as the initial value. M, the coefficient of x, is the slope. Slope is used to find points on the graph if you have a starting point, and typically the starting point, since slope-intercept form, is the initial value. Point-slope form, this is the most important of the forms, because to use point-slope form, you need two things: any point on the line and the slope. That makes it more powerful than slope-intercept form, because slope-intercept form, you must have a specific point, the y-intercept. This is used for any point on the line and the slope. So in this case, x sub 1, y sub 1 is a point on the line, and m again is the slope. Let's continue. Types of slope. Imagine that you're moving from left to right on this line. Notice you're going up. Since you're going up from left to right, it's a positive slope. If you're on this line and you're sliding down from left to right, it is negative because you're going down. A horizontal line has a slope of 0, and a vertical line has an undefined slope. Also like to mention that if you have a horizontal line, it's always going to be y equals a number, that number being the y-intercept. If you have a vertical line, it's always going to be x equals a number, that number being the x-intercept. Moving on. Find the slope of a line containing these 2 points. Well, let's write down the slope formula. You must use this formula every time you do one of these problems, or you will not receive credit for it. Delta y means subtract your y values. I'm just going to go from left to right. So I'm going to take 6 minus 4 over subtract your x's. 4 minus a negative 3. Simplify, 6 minus 4 is 2. 4 minus a negative 3 is 7. The slope is 2/7. Had someone else done it in the opposite direction, if they would have went 4 minus 6 and negative 3 minus 4, they would have ended up getting a slope of negative 2 over negative 7, which reduces to 2/7. Same thing. Doesn't matter the order in which you do it, as long as you use the same point for x and y first and the same one for the second one. Number 2, we're supposed to graph y equals negative 2x plus 5. This is currently in slope-intercept form. So the one point that we know is the ordered pair 0, 5. It's the initial value. That's here on the y-axis. Let's label that. The slope of this line is negative 2. So from the point that we have, we go down 2 to the right 1. It's going to put us here. You don't need to draw those little arrows. I'm just illustrating. We continue to go down 2 and to the right 1. Or you could also go up 2 and to the left 1. Why is that the same thing? Because negative 2 over 1 is the same as 2 over negative 1. To be clear, this negative 2 says go down 2. This says go right 1. If you write it this way, it says go up 2 and to the left 1. Either way, you're going to be on the same line. If you use your company-issued straight edge, you're going to find that your line looks something like this. Make sure that you draw it long enough that it intersects both the x and y axis. Number 3, you're supposed to graph x equals 6. If it's x equals a number, that's a vertical line, and this vertical line is going to be, whenever the x value is 6, that is crossing the x-axis at 6, usually a company-issued straight edge. Label that point of intersection. Now, what I'm asking you to do is, like, you might be thinking, what am I supposed to label? Label the y-intercept if it has one. If it doesn't have one, like this one, then label the x-intercept. Also should mention, since we just graphed 2 different lines on the same coordinate plane, we look at this later, we're not going to know which one is which. So anytime that you have more than one line on the same coordinate plane, you are required to label each of them. This is x equals 6, and this one here was y equals negative 2x plus 5. So label them so it's clear which one goes with which. I'll put that here. Number 4, we're supposed to graph y equals negative 5. Y equals a number is a horizontal line. So it has a y-intercept of negative 5. So that means that it goes down 5 all the time. Doesn't matter what the x value is. This y-intercept is 0, negative 5. Labeled the y-intercept, and I labeled the line because we have multiples on the same coordinate plane. Number 5, write the equation of a line with a slope of 5 and a y-intercept of negative 3. We could do this using point-slope form or slope-intercept form. I'm going to choose to use slope-intercept form for this problem because we explicitly are given a slope and a y-intercept. So y equals mx plus b is slope-intercept form. We know the slope is 5. We know the y-intercept is negative 3. Finished. Number 6, write the equation of a line that goes through this point and has a slope of negative 2. I wonder which form you should use if you're given a point and you're given a slope. It's the most powerful of all the forms. It's point-slope form. Once again, why is this more powerful than slope-intercept form? Slope-intercept form requires you to have a specific point. Point-slope form says you can have any point you want on the line. Point that we're given is negative 3, 6. The slope we're given is clearly negative 2. Every time you use point-slope form, please write it out first. Then substitute. y1 is 6. The slope is 2. The x sub 1 is negative 3. Let me rewrite my 3 better. My 3's continue to get lazier and lazier. We can stop. The problem, I'm sorry, I made a mistake here. My apologies. Slope's a negative 2, and I wrote positive 2. Now we can stop. The direction said, and I quote, write the equation. It does not tell us what form to use. So once you have an equation of your line, which we do right here, we can stop. If it bothers you to have subtracting a negative, change it so it's plus 3. If you'd rather write this in slope-intercept form and do more work, go ahead. But keep in mind that every step that you add to this increases the chance of you making a mistake. It says write the equation, we did it, I'm going to stop, and I would encourage you to stop as well. Write the equation of this line. Now, fortunately for us, once again, we have lots of points on this line we could name. Keep in mind there's an infinite number of points on this line. For example, every place this arrow is pointing to is a point. It's an ordered pair. Now I suggest you use ordered pairs that are clearly whole numbers, integers, I should say. But you don't have to. Definitely would. This problem, we can see explicitly what the y-intercept is. It's negative 6. We also know explicitly what the slope is. If we go down 1 into the right 3, we're going to have a slope of negative 1/3. Therefore, the equation of our line, if we use slope-intercept form, is y equals negative 1/3 x minus 6. Could you have used point-slope form for this? Absolutely. You could pick any random point on this. Let's say you chose this point, which is negative 3, negative 5. You could have written y minus a negative 5 equals the slope of negative 1/3 times the difference of x and 3. It's a lot messier than this one here, but they both work. Both of them are appropriate. One thing I would add to this, if I was doing it this other way, is you would want to write down this formula before you plug the stuff in. Otherwise, it's essentially the same. Number 8, write the equation of a line through these 2 points. Do we have the slope? No. Do we have the y-intercept? No. I wouldn't use slope-intercept form. Now, if you're thinking we could find the slope, I agree with you. If you're saying we could find the y-intercept, I also agree with you, but I wouldn't bother because we already have a point. If we simply use point slope form, all we need is a point and a slope. We already have 2 points. I'm just going to choose this one. Someone else could choose negative 3, 1. That would be correct. And then we're going to find the slope using the slope formula. Once we have those things, then we can put this into point slope form, which is y minus y sub 1 equals the slope times the difference of x and x sub 1. Using the slope formula, if you subtract your y values, it's going to be 1 minus 8. If you subtract your x values, it's going to be negative 3 minus 4. It's going to be negative 7 over negative 7, which is 1. So in point slope form, we're going to have y minus 8 equals 1 times the difference of x and 4, finished. If you don't want to put this 1 here, just leave it blank because 1 times anything doesn't change it. That would be fine. But that is an equation. It is the equation. Doesn't say what form to put it in, so we can leave it like that. 9. Graph this line. In order to graph a line, you essentially need 2 points. One of the points we are actually told implicitly, this here is the y-intercept, the constant 1. Well, how do we find another point? Because I said that we just need 2 points in order to graph a line. Well, the slope gives you directions on how to find other points. Our slope for this is negative 3/2, which you can think of as negative 3 over positive 2, or you can think of it as positive 3 over negative 2. Those are all the same things. Let's say that we choose this one. We're going to go from our ordered pair 0, 1. We're going to go down 3, 1, 2, 3, and to the right 2. We get a point right here. If someone else would have rather gone up 3, 1, 2, 3, and to the left 2, you'd have a point right here. Now you might be thinking, you said we just need 2 points. Why did you add 4 points? Keep in mind that a point has no dimension, and I have just made these points have 2 dimensions, length and width. So my point is, well, let me show you what my point is. Let's say I didn't do these 2 right here. Let's ignore those for a second. I just did these 2 that were here. I could draw a line that went through those. See how it's touching both of those? And yet it's really getting far and far away from these. So what happens when your point has thickness? So long story short, the more points you have, the more difficult it is to put your line in the wrong spot. Use your company issued straight edge. Label the y-intercept, please. You don't have to label this line because we only graphed one line on the coordinate plane. Finished. Number 10. Write the equation of the line that goes through these 2 points. I would once again use point slope form. We need a point, such as 0, 4. We need a slope. Slope is the difference of y's over the difference of x's. Our y's are 1 and 4. Our x's are 4 and 0. We get a slope of negative 3/4. And then we can write the equation in point slope form. So y minus y sub 1 equals the slope times the difference of x and x sub 1. Y value, I chose 4 because I chose this point here. You could have chose the other point. You have a different looking equation, but it's the same line. Equals negative 3/4, and then I'm running out of space here. Apologies. X minus 0. We can leave it like that. If the minus 0 bothers you, continue to simplify it. I wouldn't. This is our equation. Finished. Thank you very much.